example here. Same thing, like I was mentioning, find the center vertices, foci, and the equations of the asymptotes. That's the only kind of extension that we're going to do for this problem. We have to understand that this is a hyperbola, and when we look at the coefficients, or rather, it's the same, similar to the ellipse. The x and the y are squared, but different signs for the coefficients. So if I look at this 9, it's positive. I look at this -1, it's negative. So that's how I know it's a hyperbola. If they were the same sign, it would just be an ellipse. The procedure is going to be very similar to the other ones. We're going to complete the square. So I have to group the x's and the y's together. So I have 9x squared minus 36x minus y squared minus 6y. And then this 18 we can move over as -18. Now, before I can start completing the square, I have to basically, don't forget to factor out these coefficients. And the one that students kind of forget is that negative also has to be factored out. You can, if you want to, you can write a -1 in front. Okay. So it's going to be 9 parentheses x squared minus 4x on this one, and then -1 parentheses y squared. And be careful here. I'm factoring out a -1, so -1 times what gives me -6? Yeah, but then, but 6, but it has to be positive. That's the main thing that I want to emphasize there, is that be careful with the sign change because of this factoring out here. Alright, and now I can complete the square in both of these. And the setup is, I'm going to do the setup, 9x squared minus 4x plus some blank. And remember, we talked about this, it's basically going to be this coefficient divided by 2 and then squared. If you want to evaluate and put the result there, that's fine. But remember, when we condense it, it really doesn't affect what this number is. At the end over here, it will. Y squared plus 6y plus, again, this time the coefficient is 6. 6 divided by 2 squared is equal to -18. And I have to balance things out. So I have to add to both sides whatever it is that I was adding. Okay. So on this one, I added this one. -4 divided by 2 squared. But I want to make sure that you understand that there's 9 of these in front, so there's 9 also over here. And over here, I'm going to be adding, yeah, well, yes, it's going to be 6 divided by 2 squared, but yes, that coefficient has to match. This coefficient in front is -1, so I have to put a -1. That's also the one that students kind of make a mistake on. If you wanted to, if you could change it to minus right here. But I'm just going to go ahead and leave it here. When you enter it into the calculator, it won't make a difference. But yeah, you can evaluate it that way. Alright, so now it's going to be 9. I don't know why I had these as parentheses and then brackets. It's going to be 9 parentheses. Remember, when we condense this, it's going to be x minus 2 squared minus 1 y plus 3 squared. If I evaluate all of this right here, what do I get? What is this? 4 divided by 2, 36 here, minus 18, 18 minus 3. Did I do something wrong? Oh, this should be squared. So 18 minus, I got 9. Yeah, because negative 18, this one right here, all of this is what? 4 divided by 2 is 2. Negative 2 squared is 4 times 4 is 36. This one right here is negative 9 because, yeah, so this right here, 36 minus 18 is 18 minus 9 is 9. And the same thing as the standard form for the other ones. The standard form, notice how it's always equal to 1 even for the ellipses. The only difference is that for parabolas it's not. So I have to, the last step is, yeah, divide by 9 to equal 1. Whatever I do to one side, I have to do to all the other sides. Now this fraction right here, 9 over 9, it just reduces to just x minus 2 squared minus y plus 3 squared over 9 is equivalent to 1. Now if you want to go ahead and leave it like this, that's fine. Or if you want to put that over 1 so that you can see, or so that we can use later on to for a sketch, then you can do so. But understand, in some cases, they don't always put that coefficient in the bottom. The same thing as x, they don't necessarily put a 1 in front. Alright, so that was the goal, to get it to what this book calls standard form here. And now let's go ahead and start sketching this. What's the center point here? Yeah, so be careful to negative 3. Along the x, you get the opposite of this one, transformations right there, or translations, and then opposite of this, negative 3. So let's go ahead and start sketching this. We're going to be at 2, negative 3. Might need to extend this more than that. So let's start sketching our center point, 2, negative 3. Here's my center. And then you do the same thing as we did in the ellipse. Underneath the x, you look at this coefficient. You take the square root of that. That's how many units you're going to travel along the x from the center point. So I'm going to move 1 unit this way and 1 unit this way. And then along the y, you take the square root of 9, that's 3. You move 3 units along the y, 3 units along the y from the center point. Now, the difference here from hyperbolas to ellipses is that normally from here we would go ahead and draw the ellipse, but since this is a hyperbola, use that minus, I'm going to instead have to draw a rectangle that encompasses this right here. And the diagonals that go through this rectangle. On this one, just be careful. You want to make sure that, well, I don't know if you guys are using grid paper, but if you are, you want to make sure that you either follow the slope so that you maintain the same line throughout. Or you can just use a straight edge, a ruler. Yes. It was from here, remember, from the center point along the x, I look at the denominator right here, I get 1. So the square root of 1 from this center point along the x axis, I'm going to move 1 unit this way and 1 unit that way. For the y, you look underneath that and you take the square root of that. The square root of 9 is 3. So I move 3 units up and 3 units down. And then I just enclose this with a rectangle. Alright, now I have to determine which way is this parabola opening up. Okay, and for that, I need to look at the standard form equation, and just be careful. This final equation, once it's completed, completed the square and it's equal to 1, this is the one you look at which one is positive, the x or the y. Well, no, because here that minus is going to make all of this negative, so it's the x. So that means along the x-axis, it's going to open up, so the transverse axis around here. So that means that this graph is going to do this. It's going to open up along this direction, and just be careful that you use those asymptotes to guide you, that you cannot cross over those, but you will approach them as you get nearer to them. Yes. Uh, no, no. It's if like let's say if this one's like the other way around, like there was a negative or a minus in front of this one, then that means that the y is positive. So instead of drawing my hyperbola this way along, opening up along the x direction, I would do a parabola this way and this way, up and down. No, no, no. No, don't distribute this negative into here and then change it over here. No, that stays the way we normally leave it like that. All right, so by the way, these points right here are your vertices. Okay. So all I have to do now is determine what are these vertices, or what are the coordinates where I'm at these points. What is it? 1. Remember, I'm at 2, so 1 this way, so 3, -3. And now the only thing that also changes here for the foci, if you look at it right here, the equation changes up. It says c squared is equal to a squared plus b squared. Before, it was minus, and also a little bit about the a and the b. Last time for the ellipses, I kind of mentioned the a was the bigger one. This one, not so much. This one, it just depends on what axis you're on over here. Okay? So if it opened up along the x, then that becomes your a. So it's basically the a is the one underneath the positive variable. Okay, so if the x is positive, underneath it is a, regardless of if it's the smaller one or the bigger one. Okay, so if I go back to this one, the one that was positive was this one right here. So a is equal to basically the square root of this one. So a is basically this one right here. Okay. So now let's just do this. I'll explain why I wanted to differentiate between the a and the b, because right now for eccentricity it's going to be needed. So let's go ahead and find the foci. Again, it's c squared is equal to a squared plus b squared. Um, so c squared is equal to a squared is 1, b squared is 9. Right, so I get, yes. So this is going to be the square root of 10. And now, if you want to give the approximation, since we're sketching this, I believe this is 3.162. And that way you know more or less where to plot your points or your vertex points right here. So from the center, I'm going to move 1, 2, 3, and then point 16 or point 0.16. So just more or less, it doesn't have to be exact. There's a focal point right there. Another focal point. And remember, everything's from the center point along the transverse axis, where hyperbola, the transverse axis, is the one that, or how would you determine which transverse? Is it the horizontal? Is basically you look at the x-axis is horizontal. I'm sorry, you look at the positive, and in this case, the x was positive, the x-axis is horizontal, so that's why everything happens along this horizontal, and the graph also opens along this horizontal. All right, so what are the coordinates, by the way? Remember, from the center point, I move square root of 10 units this way. So which one changed, the x or the y? Yeah, so it's going to be, Okay, so but just yeah, just make sure that you give me the exact answers. Like you would say 2 minus square root of 10, comma, negative 3, and 2 plus square root of 10, comma, negative 3. If you want to give the approximations, by all means, but I do want these exact answers, at least when you enter them into the into the calculator. All right, the next thing that we're going to look at is the equations of the asymptotes. Y2 what? To what? Because there's one here and one here. From the center point, one goes this way and one goes that way. From the center point that we got over here. Two negative. Yeah, because from here, yeah, it's remember this distance from the center point. Oops, from the center point this way is square root of 10 units, and this distance is also square root of 10, but I'm going in the negative direction. So I'm giving the coordinate value here is 1, 2. So here's my value at 2. If I move square root of 10 units that way, I'm not going to be at 2 anymore. I'm going to be at 2 plus the square root of 10 units that way. Or if you want to give the approximation, you would say the coordinate here is you're going to be at 5.16 comma negative 3. Whatever what first answer was. Yes, everything is related to the center. Everything's based off on the center. The vertices from the center, the focus or the foci from the center. All right, now the equations of these asymptotes are we're going to look at now. To distinguish both of these, I'm going to go ahead and label this y1 and y2. And now remember, to get the equation of any line, we're going to use point slope form, which is y minus y1 equals mx minus x1. It's probably the easiest one to use. And now what I like to use, since I'm going to need the equation of y1 and I'm going to need the equation of y2, I generally like to use this point, the center point. Since we kind of used it for everything else, the center point is common for both of them because it's the intersection point. So for y1, I'm going to use the points 2 comma negative 3, and the slope is what? So I look at my sketch, and I generally like to use these corner points and then go to this center point. So rise is 3, run is 1. So what is the slope? Yeah, 3 over 1, which is 3. For y1, this one right here. 1, 2, 3, rise 3, run 1. So I get 3 over 1, 3. All right, so now let's just go ahead and substitute this into the point slope formula. So it's going to be y minus y1. Remember, this is y1, this is x1, which is negative 3, is equal to m, which we got 3, x minus the x value that we got, which is 2. Okay. Remember, this right here is x1, this is y1, so y minus y1, negative 3, and then just simplify this. This becomes what? Y plus 3 is equal to 3 parentheses x minus 2, minus 3 minus 3. I get y1 is actually equal to this right here. Now, I'm okay if you leave it at this point right here. It's not going to matter to me because when you enter it into the calculator, if you enter this one, or if you want to simplify, like distribute and change it to slope intercept form, by all means, go for it. The only thing is, like I said, because some of these problems can be rather lengthy, if you leave it there, I'm okay with that. All right, so now do the same thing for y2. And I'm going to use the same point, but this time, what's the slope? so let's look at my graph. Yeah, if I look at my graph, y2 is going this way, so you can choose any vertex. Like you can go from this point, I go up 3, but 1 to the negative direction. So the slope is, well, I'm pointing to this one. Like y1 is this line. It doesn't matter. But do you see how like this is y1, like this line right here? No, it's just here's the endpoint right here. So this line right here is y1. This one is y2, so I'm going this way. I mean, yeah. It doesn't matter. If you want to label it a different way, it's fine. But the slope is important for that. You distinguish for y2, it's going to be up 3, 1 to the negative. So it's 3 over negative 1, which is negative 3. All right, and now just input this. I get y minus negative 3 is equal to negative 3 x minus 2. This is y plus 3 equals to this. And I get y2 is equal to negative 3 x minus 2 plus, I'm sorry, minus 3. All right, so there you have all the information for a hyperbola, and this one does have a little bit of additional information. I don't want you to get too, think this is too much, but you should already be familiar with getting the equation of the line, so I don't want, for you to have too much trouble with that. And that's why I'm saying you don't have to necessarily simplify it up that much. All right, the next thing that I would like for you to do, and again, this is only going to be during class because on the exam I disabled that option, but it is a meaningful way to check to see that you're doing this correctly. So I have all this information. I've got my vertices. I've got this. I'm sorry, the focus points or foci, vertices, center. But now let's go ahead and check it. So if I go to my calculator, if you go to your graph, if there's anything on there, easiest thing is go to hit the document button and then go all the way to the very bottom where it says clear scratch pad. So do that right now, and it's gonna default. It's actually gonna change you back to the calculator. Go back to the graph page. It's gonna default to graphing functions, but I don't want to graph function. So if I hit menu and I go down to graph entry edit line, I want to go under the one that says equation. And you can see, you kind of see the different conics right here. Just be careful that these right here, the parabola, circle, ellipse, hyperbola, that's in what the book calls standard form. But since I was the one who did that, for all I know, I could have made a mistake. I'm going to instead choose the one that says conic and the general one, because that's the way our equation started off as. We started off with this equation right here. So I'm going to type this equation into that option right there. So hit enter here. Notice how your entry line now becomes the general conic. So let's go ahead and type 9x squared minus 1y squared. So 9x squared, there's no xy, so make sure that you put a 0, minus 1y squared. And let me arrow out over here so you can see these numbers over here. So I need the number in front of the x, which is negative 36, and then minus 6y plus 18. So negative 36 minus 6y, and then just plus 36. Was it plus? No, plus 18. Sorry. And then hit enter. At least it'll give you a visual confirmation at the very beginning. We sketched this. We were kind of on the fourth quadrant. My graph, when I compare it, looks more or less like it's that. If you want to move your screen, just kind of hover above on the calculator, control click, and then drag your screen, a little bit up if you want to. Stuff is going to get on the way when we start applying labels. So I'm going to move this equation label, and I'm going to just drag it to the very bottom. All right, now let's go ahead and get all our information. You guys remember how to do this? Just hover above it until it gets bold, and what do? Control menu. That's one way of doing it. Another way is just to actually hit the menu and it's under Analyze Graph. And then down at the bottom, Analyze Conic. And then I can get all the information that I pretty much found. So I hit enter on the center. And you can see that the center point is in fact what we got. Let me put that up here. Now let's go back to it. So hover above the graph, control menu, analyze graph, analyze conics, and vertices, and there they are. Again, to remove the labels, hover above them. Once you see that little hand that's opening up, control click, and just drag it out to somewhere convenient where you can see the number. Um, the foci are next, so hover above it, control menu, analyze graph, analyze the conic. Now let's go to foci. Now again, the only thing about the foci is that it's going to give us the approximation, not the exact one. Okay. And what you could do is we got, that's what I'm saying, if you want to go ahead and put the approximations down here, like this one right here, I can just go to my calculator and do, 2 minus the square root of 10, and you see that it is in fact, this negative 1.162, and it kind of confirms that on my calculator. You have this negative 1.162, and you can do the same thing for this one. If I do 2 plus the square root of 10, I get 5.1628, which is what we got for the x over here. Alright, the last thing that this calculator is capable of doing as well is if you go back to Analyze Graph, Analyze the Conic, it will also give you the asymptotes. Now, the only thing is that what do you notice about the asymptotes? Okay. But what the equations? How did they give us the equations? Right, they actually distributed, it's basically they gave us in slope-intercept form. So if we got this right here, I mean, if the calculator got this, and you wanted to confirm your work, there's a couple of things that you can do. You could just, graph these two equations that we got by changing the entry line back to function, or just solve it. I mean, it doesn't take that long. 3x minus 2, not solve it, I'm sorry, simplify it. Distribute 3x minus 6 minus 3. So 3x minus 9, which if I go to my graph, 3x minus 9 is right here. And if I distribute this one down here, negative 3x plus 6, because negative times a negative, combine like terms, negative 3x minus plus 3, I'm sorry. And like I said, the y1 and y2 were my labels, so that I know which one's which. But then I'll explain how you're going to submit them, and it won't matter just as long as you get both of them correct, though. All right. Again, this calculator is very powerful to give you most of the work for you. But again, don't rely on it. I am right now. I'm leaving this option available to you because you can see how it's a lot of work involved in one problem. I would hate for you to be doing everything and then you're not checking them, and then at the very end you find out that yeah, you were doing them wrong. So that's why I do want to leave this option available right now so that you can check your work and correct yourself as you go with this. But on the day of the exam, I will disable that option. So just be careful. Don't rely on it's just going to be on there. All right, so let me go ahead and send you a example so that you can try on your own. And I don't think you can see it on the calculator, so I'll write it down.